Hello everybody, welcome to grade 12 winter school. In this video I will discuss Euclidean geometry. Now the final question draws on your grade 12 knowledge of similarity and proportion. Don't be intimidated by this question. It's a great opportunity to showcase your understanding of these important theorems. To help you prepare, I have put together a playlist filled with examples and explanations of the grade 12 theorems, and I highly recommend taking a look at those videos to refresh your memory and boost your confidence. By doing so, you'll be well prepared to tackle this question. Now you see the question here, and it's a combination between grade 11 and 12 similarity, and there you can also see at 10.1.3 they want you to prove the two triangles similar. Remember, you need to prove two angles equal, and then the third angle will be equal because of angles of a triangle. And then there's 10.2. Once you have the triangles similar, then you can write down the proportions. But let's do the question together.
In the diagram, a circle passes through D, B, and E. Diameter ED of the circle is produced to C, and AC is a tangent to the circle at B. M is a point on DE such that AM perpendicular to DE. AM and chord BE intersect at F. 10.1. Prove giving reasons that number 1. F, B, D, M is a cyclic quadrilateral. So we start by saying that angle DBE is equal to 90 degrees. That is that angle over there. And the reason is angle in semicircle because DE is a diameter. Then we can say that angle M2 is equal to DBE is equal to 90. They are both equal to 90. Therefore, FBMD is a cyclic quadrilateral. And your reason is it's the converse of the exterior angle of a cyclic quad. So what that theorem actually says is if the exterior angle is equal to the opposite interior angle of a quadrilateral, then it is a cyclic quadrilateral. Where's the marks? The reason, angle in semicircle, that statement, and your reason. 10.1.2, prove that B3 is equal to F1. So we start by saying that B3 is equal to D2. B3 equal to D2. And your reason is it's the tan chord theorem. The angle between the tan and the chord is equal to the angle in the opposite segment. Then F1 is equal to D2. There's F1 is equal to D2. And your reason is it's the exterior angle of a cyclic quad is equal to the opposite interior angle. So we've got both of them, B3 as well as F1, that's equal to D2. Therefore, B3 is equal to F1. And then where's your marks? Statement reason, statement reason. 10.1.3. We need to prove that triangle CDB is similar to triangle CBE. CBE, that big triangle. Right, we start. In triangle CDB and triangle CBE, we get that the angle CBD is equal to angle CEB, and the reason is it's the tan chord theorem. Then we see that angle C is the common angle. Therefore, triangle CDB is similar to triangle CBE and your reason is angle, angle, angle. 3 angles equal. Where's the marks? Statement, reason, statement, reason, reason. 10.2. If it is further given that CD is equal to 2 units and DE is equal to 6 units, calculate the length of BC. Now, since our two triangles are similar, we can write down this ratio. It is CD over CB is CB over CE. And then we can say that because our triangles are similar. Then we can cross multiply. CB times CB is CB squared and CE times CD. Then we can substitute the values. It's going to be 8 times 2. Where does the 8 come from? CE's length consists of CD and DE. So you add the two together. And then CD is 2 and 8 times 2 is 16. Therefore, BC is 4 units. And then where's the marks? Your ratio, CE 8 and BC 4 units. 10.2.2, find the length of DB. So before I start, I just want to show to you that on the sketch, remember CD was 2 units and DE 6 units and CB 4, because that's important. We're going to use that now. Right. In the previous sum, we proved that CDB is similar to triangle CBE, which results in the ratio CB over CE is DB over BE. And we can say that because the triangles are similar. Then BC is 4 and EC is 8. And we can write that ratio 4 over 8 as 1 over 2. And then it is actually this thing is then the same as 1 over 2. And then when you cross multiply, you get that BE is 2 dB. That's important. We move to the theorem of Pythagoras. In triangle DBE, we can say that DB squared plus BE squared is equal to DE squared, the theorem of Pythagoras. And then in BE's place, we have that BE is 2 dB. So I'm going to substitute that. And then this 2 squared will become 4 dB. And you add that, you get 5 dB squared is 36. You divide away the 5. You take the square root and you get that dB is 2,68. Where's the marks? The ratio BE equals 2 dB. Substitution into theorem of Pythagoras and final answer.
I hope my explanation of the syllabus and the papers helps you feel more confident and prepared for your exams. This is Miss Pythagoras signing off till next time.